Alrighty, here we go. We are doing the learning target number 1, examples. I have not already made an answer key, so I'm doing this live without a net. I do not know what the answers are to any of these questions, so let's see if I can do them. Alright, I'm not going to start with mastery. That's too hard. Let's start with basic. So I like to go in reverse order. I'm going to start with basic. So get yourself a piece of graph paper to do this on, because you're not going to be able to do all of these on this sheet of paper. So number 1, I mean, if you did already do them on that piece of paper and you made it fit, fine. But I write really big. So I'm going to do 1 basic problem A. So limit as x goes to 1 from the left of f of x is equal to 5. Okay. Explain the meaning of the following notation. All right, so we're just writing this out in plain English. As x approaches 1 from the left, the function f of x goes to 5. Or, another way of saying that, y approaches 5. So as x approaches 1 from the left, the function f of x goes to 5, or y approaches 5. So I could actually even make a little example of that. Ooh, that'd be a cool thing to do. So as x approaches 1, here's 1. So as I'm getting close to 1, my y from the left, my y value is going to approach 5. Let's call this, we'll call that 5. So my function is going to approach 5. Might get there, might not. So I could put it like a hole, and there you have it. Okay, so there's an example. As x approaches 1 from the left, here's x is 1. I'm coming from the left. F of x, the function, goes to y. That means that y is approaching 5. Right? I kind of like that. Let's add examples to these. All right, B. The limit as x approaches 1 from the right, that's a little positive thing, f of x goes to 4. Right, so this is coming from the other side. So as x approaches 1 from the right, I'm going to write it with the letter y this time. Y approaches 4. So there's another way of writing it. I could even make a little example to really show the teacher I know what I'm talking about. So again, here's 1. This time I'm going to make that be 4 instead of 5. Whoops, I'm off the edge of the page. Sorry about that. I'm keeping an eye on myself. So as I'm approaching 1 from the right, y is approaching 4. So in other words, it's coming here. So I've got something like, I don't know, it doesn't matter which way it's coming. So, but it has to be coming from the right. Okay, so there's an example of that. And letter C, the limit as x approaches 1 of f of x. Oh, I got a D and E. This could mean a couple of things. So I could relate it back to these two. Since x is approaching 1 for all 3 of these, from the left, from the right, I could put these two things together and could say that, well, therefore, f of x does not have a limit at x equals 1. Okay, so this could mean a couple of things. If we're still talking about the same function, if these are all referring to the same function, then the limit does not occur as x goes to 1. It does not exist because I'm approaching 2 different values from the right or the left. But if I'm not talking about the same function here and here, this is a totally different function, then I might assume that as x approaches 1, y goes to infinity. So it could be 2 different things that could be happening here. So I could write as x approaches 1 from both sides, y approaches two different values, or, I'll make it a big or y approaches infinity, positive or negative infinity, doesn't matter. Okay, so if I wanted to make an example of that, I could actually use, let's make this 2, 4, so that would be 5, right? So I could actually combine my two previous examples into one example. From the left, I said it's approaching 5, and from the right, I said it's approaching 4. So I could have like a function like this. Therefore, at x equals 1, the limit does not exist. So here is a very thorough explanation showing that I understand what this means. Or if it's approaching infinity, that's another reason why I could have it does not exist. Say if these f of x functions that I'm referring to here are different ones, I could have at 1, I could have an asymptote. And I could have something like this. And something like this. So as x is approaching 1, notice from this side it's going up to positive infinity, this way it's going to negative infinity. Either way, the limit does not exist. Okay, so here's one possible example of that, and here's another possible example of that. Okay, so that was basic. Boy, basic seems pretty hard, doesn't it? But you got to understand what this notation is saying. All right? If you don't understand what the notation is saying, if you can do it algebraically, who cares? All right, question 2. That's why that was the basic. You got to understand. All right, number 2, approaching proficient. They give us a graph, so let's just look on here. Approaching proficiency, I can use the limit of the functions using a graph. Below is the graph of a piecewise function. Evaluate the following limits. If the following limit does not exist, write dne. Okay, remember in class today, I wanted you to write why it's dne also. Okay, so as x approaches negative infinity, so negative infinity on x, that means going all the way to the left. So if I keep going this way to the left, where's my function? Oh, it's over here. What y value is it approaching? Well, there's an asymptote here. So it's never going to cross negative 5. Okay, these are pretty easy. I'm going to just write them right here on the paper. That's fine. That approaches negative 5. Okay, this one, as we approach infinity. So since there's no sign on this one, that assumes it's positive infinity. Just like any number, if I write a number, like up here I have the number 5, that's positive 5. So if I don't put an actual plus sign in front of the infinity, it means it's positive. So as I go to positive x values, so as x values keep getting bigger and bigger, well, I have to follow this line. Oh, this keeps going down. See how it crossed that asymptote? It's going down, 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 down. So it's going to, y values are going to negative infinity, but we said that's really not a limit, so that's when I would write dne. Does not exist. The limit actually doesn't exist because it keeps going forever in that negative infinity direction. All right, next one is x approaches negative 3. Okay, here's x is negative 3. Notice it doesn't say if it's from the left or the right. There's nothing over here, so that means I have to talk about both sides. So as I approach from both sides, so I'm going to follow it up. I'm going to, both sides are going to positive infinity. So this whole thing, the y values are going up, 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 up. Remember, we're talking about the y values. So this is going to positive infinity. But what is positive infinity? It's not actually a limit, so we're going to write dne. Okay, again, I want to see both things. All right, limit as x approaches 1, positive 1, from the left-hand side. That negative means from the left-hand side. So as I approach positive 1 from the left-hand side, what y value am I approaching? I'm approaching negative 2. Right, so there's those 4. All right, next, number 3, I can find the limit of a function from its equation. So in other words, if you can do 1, 2, and 3, I'm happy. Number 4 means you really got it. Okay, so let's see what happens here. Notice it's approaching a limit at infinity, and it says without using a graph. So I'm not going to touch my graphing calculator here. And I need to justify my answers. Okay, so I'm going to do that over here then. So number 2, that was on, I did that on handout. So number 3, proficient, problem A. I am going to do the limit as x approaches positive infinity of 12x squared minus 3x all divided by 4x squared plus 5. So notice what we have here. We have, if we put in a really, really large number for x, these guys over here, 3 times x and 5, these are going to become insignificant. So basically this is the same as saying 12x squared over 4x squared. And so the x squareds are going to cancel out, and I'm just going to be left with 12 over 4. So this is really approaching just 12 over 4, which is approaching 3. So notice the degrees on the top and the bottom, and the numerator and the denominator. We have x squared over x squared. So denominators and numerator have the same degree, So in that case, we're just left with a coefficient, so it's going to be approaching 3. Okay, letter B. We have the limit as x approaches negative infinity of 5x cubed plus 2, all divided by 3x squared minus 8. So again, we're going to infinity. Oh, but notice this is kind of interesting. This time it's going to negative infinity. So we're going to have to think about this maybe a little bit. We're going to negative infinity. So in other words, these x's are going to become really big negative numbers. So these two over here, the 2 and the 8, are going to become insignificant. And notice this one is bigger than the one on the bottom. So this one's going to become way bigger. This one's not going to become so big. This one's going to get really, really, really big. So as I go to negative infinity, this is also going to go to negative infinity because this x squared down here, who cares? Another thing to think about, if you take a negative and you cube it, a negative times a negative times a negative is still a negative. And then if you square it, negative times a negative is a positive. This whole thing is going to end up being negative. So my answer is going to be negative infinity. And why? We're really looking at this part right here. So x cubed over x squared. The higher degree is on top. Higher degree. That means that I could write this out. Think about it this way. I could do x times x times x over x times x. If we think about simplifying that, I'm left with x. What is x? Negative infinity. Oh, so there's another way of thinking about it. Okay, so these numbers become insignificant. And I could still have my 5 and my 3. Actually, we could keep that. So if you wanted to, I could write this as 5x over 3. 5x over 3. And if x is infinity, well, who cares about timesing by 5 and divided by 3? It's still going to infinity. But in this case, of course, it's negative infinity. So that's how I got my answer. Okay, so these are, who cares? That's like 1 point something times infinity is still infinity. Alrighty, and letter C, I have the limit as x approaches, I don't have my glasses on, positive infinity, it looks like. Positive infinity of 5, there should have been parentheses around this. Sorry, that was a typo. This should have had parentheses, so you know that we're talking about the limit on this whole thing. Okay, so that usually on here, this should have had parentheses. That's more normal, like we did on that one. Okay, so back to this one. So if I'm putting in a positive infinity in here where this x is, and that x has a negative, that means it's going to be e to the negative really big exponent. So when I have a negative exponent, that means it's a fraction. So this is basically, I could rewrite this as 5 over e to the x, right? I can rewrite that with a positive exponent plus 9. Now, if I put in infinity here, e is 2.72. Okay, it's like pi. Pi is 3.14. E is 2.72. We saw where it comes from. It comes from compounding interest continuously, and you reach this limit of 2.72. Oh, that's another example. Where do limits occur in real life? They occur in financing when you have interest payments that are being compounded continuously, and you have that in biology when something is reproducing continuously. You get this limit of 2.72 times as many things happening. Okay, anyway, I digress. So this is going to become a really huge number. 2.72 raised to infinity is like a huge number. So 5 divided by a huge number, what's going to happen to that? That's going to go to 0. So I'm going to have 0 plus 9. So what's the whole thing going to go to? You guessed it, it's going to go to 9. So the limit as x approaches positive infinity of 5e to the negative x plus 9. I can rewrite that with my e to the x on the bottom. This is going to be a huge number. So 5 divided by a huge number is like nothing. Nothing plus 9 is 9. So that limit is equal to 9. Okay, let me box my answers here because I'm getting kind of crazy showing all my work all over the place. Okay, and the last one on this level, letter D, the limit as x approaches 3 of 5x squared minus 2x plus 1. So, oh look, they gave me a number. I don't even have to think that hard. I can just plug it in. Funny how the last one's the easiest one. 5 times 3 squared minus 2 times 3 plus 1. That gives me 5 times 9 minus 2 times 3 is 6 plus 1. Notice I'm not using a calculator. That's why it's taking me forever. 5 times 9 is 45 minus 6 plus 1. I'm going to put these two together. 45 minus 5 gives me 40. So that has a limit of 40. So as x approaches 3, y approaches 40. And I get it just by substituting it in. All right, that was level 3. Okay, level 4. So 4, mastery. What does it take to be a master of limits? You have to be able to factorize. So, oh, why does it say E? That's weird. This should say A. This should say B. Okay, so this one, limit as x approaches 0 of 3x squared plus 8x over 4x. Okay, notice x is approaching 0, so I can't use my little rule of where do I have the higher degree, because I'm not going to infinity. So remember, those rules only apply when x is going to infinity. So here, I could plug in 0 for x, like I did on problem D, but what happens when I plug in a 0 here? The whole thing is undefined, so I can't do that. So this is where we're going to factorize. I notice that everything has an x, so I'm going to factor out the x in the numerator. So I get 3x plus 8, and I can check that by distributing. X times 3x is 3x squared. X times 8 is 8x, and then on the bottom I have 4 times x. I have an x over an x. I can reduce that. That's just 1, and I'm left with 3x plus 8 over 4. Now I can substitute in my value for x. I can put in my 0, and I get 3 times 0. Oh, I'm running out of room. See, I write really big. 3 times 0 is 0. 0 plus 8 is 8. So I have 8 over 4 is equal to 2. So there's the answer for that one. That one seemed actually, my mastery problem seemed kind of easier than the others, but that's okay. You have to get all the rest right before you're allowed to get mastery. All right, limit as x approaches negative 2 of x squared plus 8x plus 12, all divided by x squared minus 4. Again, if I put in negative 2 here into my denominator, negative 2 squared is 4, 4 minus 4 is 0. So if that gives me an undefined answer, I can't just plug it in. I'm going to have to factorize it and see what happens. So on the top, x squared, I get that by doing x times x. To get 12, I could do 3 times 4, but those don't add to 8, so I think it's going to be 6 and 2. 6 times 2 is 12. And to get both of these positive, both of these have to be positive. 6x plus 2x, yep, that's 8x. Okay, the bottom is a difference of squares. X squared minus 4 Again, I'm going to have an x times an x. In order to get a negative 4, I'm going to have a 2 and a 2. One of them has to be positive, one of them has to be negative. And then I can see my x plus 2's reduced to 1, and I'm left with x plus 6 over x minus 2. And now I can plug in my negative 2. So I get negative 2 plus 6 over negative 2 minus 2. And I get positive 4 over negative 4, and my limit is negative 1. And notice I did it without a calculator. So if you want to be able to check these on a calculator, we could do that. And but notice I did everything on this practice quiz without a calculator, so that's what I expect you to be able to do on the first learning target, is actually be able to do these without a calculator. Because on the calculator, pretty much we would just be graphing it, and then it would be like this learning target, where I already gave you the graph. Okay, so that's why I'm not letting you use a calculator on this particular learning target, because the thing that you would do on a calculator, I'm providing that in paper form. So that's it. I think I did everything. So I hope you got it all right without my help, and if you didn't, I hope you enjoyed the video and understand better now. If you don't, come and see me. Come and see me at lunch. All right, bye-bye.